Hi Year 7s, I hope you're doing well. I'm just going to try and hopefully give some guidance on the Hegarty task that was been set this week. So we're looking at linear equations and solving these. And what I want to do is start off with 178 and just go through a few questions that I had when I looked at the preview questions and just talk through these. So there's two things when you're looking at these type of questions that you need to remember. And one of them is called the balance method. Now that means that effectively when we do something to one side of the equation, we need to make sure we do exactly the same thing to the other side, okay? With this equal sign, what this means, you can think of it like a set of scales, okay? So the x plus 15 equals 21. That means they're balanced at the moment. This side equals this side. And if you think of a set of scales, if you take something off one side, you've got to take something off the other side. If you put something on one side, you've got to put something else on the other side to keep it even. Okay, so the balance method just means that we're going to keep each side even. Okay. Now, the second thing we're going to think about is what Mr. Hegarty calls the inverse operations. Now, inverse operations, it effectively means if I add something, okay, you can think of this as like the opposite operation, okay? So if I have a plus, the opposite of adding something is going to be taking away, okay? The opposite of adding something is going to be taking away. If I multiply something, the opposite of multiplying is division, okay? So if we can remember that if I add something, the opposite to that is taking away. If I take something away, the opposite is adding. And if I multiply something, the opposite to that is dividing. And if I divide something, the opposite is multiplying. Okay, so these kind of two rules here with the opposites will stand us in really good stead when we try and answer this question. So what we're going to do, we're going to say, okay, I've got x here. Now, in each of these questions, we're just trying to find x on its own. We want to leave x on its own. So we want to basically keep this x and get rid of the 15. Now, if this is a plus 15, okay, that sign there is really important. That's a plus 15. So with that plus 15, what I want to do is I want to do the opposite. If I go back up here, the opposite to my plus is a take away. So I'm going to take away 15 from that side. If I take away 15, I have x plus 15, and I take away 15, I'm going to be left just with x. If I have 21, and I take away 15, because I'm doing exactly the same to each side, I'm going to be left with 6 on that side. Now I have x equals 6, so I've got x on its own, and I can know that it equals 6. If I want to check that, I can just think, okay, if I had x was 6, I could say x plus 15, so 6 plus 15 equals 21. Great, it works. Okay. Now, important thing to know, it doesn't matter if we have negatives, okay? It doesn't matter if we have negatives, and it doesn't matter if we have to leave our answer as a fraction, okay? In this case, we've got 11x equals minus 25. So first thing I'm going to do, I'm going to draw my little lines here to remind me that whatever I do on this side, I have to do on this side. Now, 11x, hopefully we remember that 11x means 11 times by x, okay? 11 times by x. If I go up here, the opposite to my multiply is divide. So if I've got 11 times by x, what I'm going to do, I'm going to divide both sides by 11. So 11 times by x, I want to leave x on its own. I divide that by 11, because 11 times by x, the opposite is divide. I know that if I'm going to do divide by 11 on this side, I'm going to divide by 11 on this side. Okay, so it'll be 11x divided by 11 will leave me with x. On this side, I've got minus 25. Doesn't matter that it's negative. And it doesn't matter that 11 doesn't divide into 25 very nicely. We all know that 11 plus 11 is 22, plus 11 is 33. The minus 25 is not in the 11 times tables. Therefore, I'm going to leave it as a fraction. It's going to be minus 25 over 11. Okay, if I divide something by a number, then I can write it out as a fraction, 25 over 11 there. So my final answer is x equals minus 25 over 11. Okay. Now, the final one I want to go through is just this one here. So this one looks a little bit more intimidating. We've got 8 over 11 equals x over 2. So we've got two fractions, one on each side. Now, what I want to focus on here is the side which has the x on. So this side has x on the top, okay? This side has x. So if I've got x here, I want to leave x on its own, okay? So I want to work out what I'm going to do to that side. Again, I'm going to draw in these lines so that I know that I'm doing the same to this side as I am to this side. If I've got x over 2, what that actually means, what a fraction means, is x divided by 2. A half is just 1 divided by 2. X over 2 is x divided by 2. So if I go up to my top of my page again, I've got multiply is the opposite of divide. So if I'm dividing x by 2, the opposite is going to be multiply. So my opposite, or my inverse operation, is going to be times by 2. So I'm going to times by 2. If I times x over 2 by 2, I'll be left with x. Now here, if I do 8 over 11 times by 2, if I'm multiplying a fraction, what I know is that 2 is the same as 2 over 1. If I'm multiplying fractions, so I can write that as 2 over 1 times by 8 over 11. I know that 2 over 1 times by 8 over 11, you multiply the top, so 2 times 8 is 16, 1 times 11 is 11. So what I've effectively done is I've multiplied that 2 by the top number here, okay, the numerator. 2 times by 8 is 16 over 11, and it's okay to leave my answer as a fraction, so x equals 16 over 11. Okay, hopefully that helps out with these one-step linear equations. My next video I'll go through two-step linear equations with the examples for 179.